So before we find the equation of the tangent, we can start by finding the gradient function. So we can start by finding a function that will give us the gradient of this curve at any point. So y will be equal to 3x squared minus 2x to power a half, if you rewrite that. And basically, this is the inside. And if we apply chain rule, we shall end up with dy over dx being equal to outside. We start with outside, so a half into 3x squared minus 2x to power negative a half, because a half minus 1 is negative a half. And then you differentiate inside, which is 6x minus 2. Now, we are interested in finding the gradient of this function at x equals to 1. So you can go ahead and say that at x is equals to 1, gradient of the tangent will be equal to, we substitute 1 in place of x in this um, expression. So we shall end up with, by the way, this expression simplifies to, because a half of each of this is just 3 and 1. So we can write it as 3x minus 1 multiplied by 3x squared minus 2x to power negative a half. So if we substitute 1 in place of x, we shall end up with 3 minus 1 multiplied by 3 minus 2 to power negative a half. So, well, this will just be 1, and 1 over 1, and then you find the square root is just 1. So the resulting answer here will be 2. So the gradient of the tangent at x equals to 1 is just 2. But you're interested with the equation. So we need the corresponding y coordinate at that point. So then to find the y coordinate, we can just substitute 1 in place of x in this equation. At x is equals to 1, y will be equal to the square root of 3 minus 2, which is just 1. So when x is equals to 1, y is equals to 1. And then here we apply the point slope formula. So y minus y1 will be equal to m into x minus x1. Now y1 is the y coordinate at the point of tangency, which is 1, and the x coordinate is given as 1. So we substitute them. So y minus 1 will be equal to, the gradient is 2 into x minus 1. So basically it follows that y will be equal to 2x minus 2 plus 1, which implies that y will be equal to 2x minus 1. And this will be the equation of the tangent to the curve at x is equals to 1. Okay, moving on. Um, we are required to find the point on the curve y is equal to 1 over 3x squared minus 6x plus 1, where the tangent to the curve is parallel to the x-axis. Now we know that when the tangent to the curve is parallel to the x-axis, it means that the tangent is horizontal. Yeah. Um, so this means that the tangent is horizontal. Now, one thing we know, that if the tangent is horizontal, that means that its gradient is 0. So dy over dx should be equal to 0. So the plan for this question is to differentiate this function and then equate to 0 and solve for x. And then because it's asking for a point, once you find the x coordinate, you need to find the corresponding y coordinate at that point. All right, so back to um, differentiation. So we can rewrite this expression this way using our knowledge on indices. So this is same as 3x squared minus 6x plus 1 to power negative 1. Now, at this point, notice that what we have inside is that. So this is what we have inside. And of course, if we apply chain rule, we'll have to differentiate inside and then outside. So dy over dx will be equal to negative 1 into 3x squared minus 6x plus 1 to power negative 2 multiplied by, you differentiate inside, which will be equal to 6x minus 6. Now, this can be written as negative 6x minus 6 um, over 3x squared minus 6x plus 1 squared. Or you can write this as 6 minus 6x um, over 3x squared minus 6x plus 1 squared. So basically what I've done here is, well, multiply 6x minus 6 by negative 1, you end up with that. And then this has negative powers, you can bring it down below to end up with a positive powers required as what I have here. But we know that this is supposed to be equal to 0, yeah? But dy over dx is equals to 0. So what that means is that we need to equate our gradient to 0. So that means 6 minus 6x, the gradient function, sorry. So 6 minus 6x over 3x squared minus 6x plus 1 squared should be equal to 0. Um, Now obviously in this case, if you multiply the denominator by 0, that'll just be 0. So we end up with 6 minus 6x being equal to 0 because this multiplied by 0 is just 0. Uh, if you cross multiply, or simplify that equation. Anyway, so solving for x, so you'll end up with negative 6x is equals to negative 6, which means x will be equal to 1. So we can see that for this particular function, the tangent to the curve is parallel to the x-axis at x is equals to 1. Now, the question is asking about a point, and the point is defined by the x and y coordinate. So we need to find the corresponding y coordinate. So at x is equals to 1, y will be equal to 1 over, we substitute 1 in the original function, so that will be 3 minus 6 plus 1, which will be equal to negative a half. Yeah. So the point where this occurs is 1 negative half. And that's basically how you solve that question. Okay, number 6. Now for number 6, we have this function and we are required to find the derivative of this function. So I'm going to rewrite it so that we can be able to apply chain rule. So f of x is equal to 1 minus x to the power a half to the power of a half. And now you can notice here that this is what we have inside. So what we can do in this case is basically differentiate it inside followed by outside. So let's start outside followed by inside. So the derivative function here will be starting with outside. So a half comes in front. Um, inside remains as it is. We'll reduce by 1. So that will be negative a half multiplied by differentiate inside, which would be, if you differentiate 1, that will just be 0. If you differentiate negative x to power half, that will be negative a half, x to power negative a half. And then we can just bring those results together. So what you shall end up with here will be um, negative a quarter, x to power negative a half into 1 minus x to power a half to power negative a half. So basically, you bring everything together, just simplify whatever you can simplify, a half and a half, negative a quarter, and then bring this in front here, and then this here. And that's just basically how you differentiate using chain rule.